Unit 9 review questions. Let's go over these answers. Number 1, which of the following is the value of the square root of 36 plus 2 square root of 25? Remember your perfect squares. 36 is a perfect square. So we take the square root of 36, we get 6. Square root of 25 is 5. So that will be 2 times 5 plus 6. Follow your order of operations. 2 times 5 gives us 10. 6 plus 10 gives us 16. So that would be number 1. Review question number 2. The expression 3 times the square root of 20 is equivalent to what? Remember that there is a perfect square inside of 20 that we have to pull out to simplify radicals. Bring down your 3. Don't leave that out because we're going to multiply that by the perfect square that we pull out. So the square root of 4 times the square root of 5 gives us 20. The square root of 4 is actually 2, so it'll be 3 times 2 times the square root of 5. Multiply the two numbers out in front. 3 times 2 gives you 6 square root of 5. That'll be number 3. Number 3, if the function of x equals 10 minus the square root of x plus 4, then what would be f of 12? So this is our input. So if we input 12, block off that problem. So you get the function of x equals 10 minus 12 plus 4. Then you just follow your order of operations. 12 plus 4 gives you 16. 16 is a perfect square. So the square root of 16 is 4. 10 minus 4 gives you 6. And that will give you number 2. Number 4, which of the following is irrational? So remember, irrational, we cannot write these as a fraction. Rational means fraction, so this one is rational. The square root of 10, notice it is not a perfect square, so this one is irrational. The square root of 4 over 9. Negative 5, we could write that as a fraction, so that of course is rational. This one is a little tricky. If you notice, these are both perfect squares, so I can simplify this to show you that it's going to be rational. The square root of 4 is 2, the square root of 9 is 3, so of course that's a fraction, so that's rational. So the square root of 10 is the only one that is irrational, so number 3. Number 5, which of the following sums represent an irrational number? All right, so here we've got 3/4 plus 1/2, and we could work this out, but when you're adding two fractions, it's either going to give you a whole number or another fraction, which is going to be rational. And we're looking for irrational, a number that cannot be written as a fraction. For number 2, I noticed the square root of 2. The square root of 2 does not have a perfect square underneath this. So anytime that you add a square root that is not a perfect square, it's going to give you an irrational number. On 3, we have 25 plus 7. So the square root of 25 is 5. The square root of 49 is 7. These are perfect squares. So when you add these two up, it's going to give you a whole number, and of course that whole number can be written as a fraction. So that's rational. Here I've got 3 over 2, and I've got 1 over 25 underneath the square root. But 1 is a perfect square and 25 is a perfect square. So this is rational plus this is rational. So when you're adding two rational numbers, it's going to give you another rational number. So the only one that's irrational is number 2. Let's look at number 6. Given the function g of x, the square root of x plus 4, which of the following values of x cannot be the domain of g? if we plug each one of these numbers in, if I plug in 1 plus 4 gives me 5, and that gives me the square root of 5. And that's acceptable. Notice that 5 is not a perfect square, but that's okay. It's a positive number. We want to end up with a positive number underneath our square root. Number 2, if I plug in -2, that would give me -2 plus 4, which would give me 2, and that would give me the square root of 2. So again, it's not a perfect square, but it is positive, so that's okay. If I plug in -5, -5 plus 4 gives me the square root of -1. We mentioned earlier in class that we do not want to have a negative underneath our radical. That gives us a non-real number. So that cannot be the domain of G. And if I plug in 12 plus 4 gives me 16, and I can take the square root of 16. So all of these numbers have in common that they have positive numbers underneath. So 3 would be our answer. We just can't have a negative number underneath our radical. Number 7. The function f of x equals the square root of x plus a plus b is graphed on the grid. Which of the following is the sum of a and b? So you have to look closely. You've got to find a and b, and then you have to add them together. If we look and base this on our vertex problems that we've done, we would have the square root of x minus, so that's -1, -2, -3, -4. But since I'm going left, it's going to be a positive 4. And then outside of the square root means I'm going to go up or down. And from the origin, I went up 1. So remember, it's opposite underneath the radical, left or right. And it is accurate up or down. So we went up 1, but we went left 4. 1, 2, 3, 4. So we're going to put a positive 4. So this is my A and this is my B. I want to add those up. It's going to give me 5. Which would be 4. So I'm going to put 4 out on the blank. Number 8. Which of the following is a solution to the set x plus 2 squared equals 25? So there's several ways that we can simplify this. One of the easiest ways is if we take the square root of both sides, and the square root symbol and the exponent of 2 cancel each other out. So that leaves me with an x plus 2. Remember that when you take the square root of both sides of an equation, you're going to have a positive square root and a negative square root. 25 is a perfect square. The square root of 25 is 5. So that gives you a positive 5 and a negative 5. Continue to solve. You'll have x plus 2 equals a positive 5. X plus 2 equals a negative 5. Subtract 2 from both sides. X gives you 3, subtract 2 again, x equals -7. So those are our two solutions, -7 and 3. And that's number 2. So we'll put 2 on the blank. Number 9, the solution set. So it looks like we got the same problem, but we're going to have different answers. Right here, we're going to take the square root of both sides, just like we did in the last problem. That square root symbol and that exponent of 2 cancels each other out. So that gives me x minus 4 equals plus or minus the square root of 20. 20 is not a perfect square, but if you remember in previous problems that we've done, that there is a perfect square inside of 20. We could go ahead and pull that perfect square out. Remember, it's square root of 4 times the square root of 5, and the square root of 4 gives me 2. So that gives me 2 square root of 5. Bring down your plus or minus, x minus 4. We're going to have to add 4 to both sides, so we're just going to put it out in front. So 4 plus or minus the 2 square root of 5 is our two solutions. And that would be number 1. Put number 1 in the blank. Number 10. Over which of the following intervals is the function absolute value of x minus 3 minus 2 always increasing? So when you're increasing, you're going up. So let's see, we could graph this on our graphing calculator. We could think about the vertex of this point. Remember that if it's inside the absolute value is going to be opposite left to right. So this would be a positive 3. This is going to be up or down. So this will be negative 2. So that would be my vertex or my turning point. And if you notice, the number out in front is invisible. It's invisible positive 1. So that means we have a function that's going up. There's my vertex point at 3 and negative 2. And we want to figure out where is it always increasing. You're going to look at your x values, which is right here. This is 3, negative 2. And again, you could graph this on your graphing calculator to get a better visual. Make sure that your plot is not highlighted. Mine was. So we've got the absolute value. Remember, that is under math, your math button. Absolute value, go under a number, and that will give me x minus 3. Go outside the absolute value and put in minus 2, or actually negative 2. Hit graph, and you notice my graph is not in the standard 3 by 10. So we need to switch this to the 10 by 10 window. So if you go to zoom 6, we get you the standard, and there we see our vertex at positive 3, negative 2. And where it's always increasing will be past 3. So x would be greater than 3, which is number 2. So put 2 on the blank. Go on to number 11. Which of the following has the same solutions? So this one is in standard form, and you always want to check to see if you can factor this one. I notice these answers are in vertex form, so we need to convert this into vertex form. Remember, the way we do that is x equals negative b over 2a. Negative b, remember this is a, b, and c. So negative 10 and another negative gives me a positive 10. So I'm going to get rid of that negative. 2 negatives give me a positive. So that gives me a positive 10 over 2 times a, which is 1. And that gives me 5. So x is 5. Plug this back in to figure out what the y is. X squared minus 10 times x plus 3. 25 minus 50 plus 3. 25 minus 50 is negative 25 plus 3, which gives us negative 22. So just the fact that I've got negative 22 leads me to number 3. Remember, this is your vertex formula, and slide over a little bit, where y equals x minus h squared plus k. So the x value goes right there, x minus 5 squared minus 22. And that is number 3 over here. So we'll put 3 in the blank. 12. When solving the equation x squared minus 20x plus 11 equals 0, use the method of completing the square. Which of the following quantities must be added to form a perfect square trinomial? All right, so we're kind of avoiding completing the square. Of course, you could take this time to research how to complete the square. I like using your axis of symmetry formula. So on this one, so when you're completing the square, what you're doing is you're taking your b value, dividing it by 2, and raising it to the second power. So for b, which is negative 20, you've got negative 20 divided by 2, raising to the second power. Negative 20 divided by 2 gives you negative 10. Negative 10 raised to the second power is going to give you 100. And that would be number 2. So you put number 2 in the blank. 13, which of the following represents the solution of x squared plus 6x plus 4? Notice your answers. One looks like you might be able to factor it, but the other 3 do not. But we can always try. Factors of 4 that add to give you 6. No, it's not going to factor. So we can put it in vertex form and solve. We can use the quadratic formula. Your choice. The quadratic formula, remember, negative b plus or minus the square root of b squared minus 4ac all over 2a. So I've got my negative 6 plus or minus the square root of 6 squared minus 4a, which is 1, and c, all over 2a, which is 1 again. So you always want to do what's underneath your radical first, just to see how many solutions you have. So here, 6 squared gives me 36 minus 4 times 4, which is 16. 36 minus 16 gives me 20. And I've got negative 6 plus or minus the square root of 20 all over 2. Now remember, the square root of 20 can be simplified to 2 square root of 5. So negative 6 plus or minus 2 square root of 5 all divided by 2. Now you're looking at these 3 numbers out in front. They're all even, so that means we can reduce this fraction. We can divide each one of these numbers by 2. So that gives me negative 3 plus or minus the square root of 5 all divided by 1. Basically, when you divide by 2, these turns into 1. So I don't need a denominator down here of 1. So those are my 2 solutions, and that gives us number 3. And we'll put 3 in the blank. However, I covered up the blank. 14. The positive solution to the quadratic equation is what? The positive solution. So notice they're giving you 2 solutions here. 1 solution, 1 solution, 1 solution. We could always try to factor it. What factors? Let's see, that's 10 times 6, so that gives us 60. Are there factors of 60 that subtract to get me 11? So I got 1 and 60, I got 2 and 30, I've got 3 and 20. 60 divided by 4 doesn't work. Oh, I stand corrected. 4 and 15. 4 and 15 subtract to give me 11. So I can use 4 and 15. Good old factoring. 4, 15. This sign tells me that they're different. This sign tells me that the largest number is positive. Don't forget to divide by 10. So we need to divide by 10, divide by 10, reduce those fractions. So that's 2 over 5. And 15 over 10 can be reduced down by 5. 5 goes into 15 3 times, 5 goes into 2 times. And we're looking for the positive solution, So if I set each one of these equal to 0 and got that on the other side, that would be a negative 3 over 2. Certainly not my positive solution. If I got this one on the other side of the equal sign, that would give me a positive 2 over 5. So that would give me number 4. So I'm going to put 4 in the blank. 15. It's going to be a long video, a lot of problems. You've got the function of the cubed root of x plus 5 minus 6. Then, what happens when f is 3? So we're going to plug in 3 here. So I've got the cubed root of 3 plus 5 minus 6. 3 plus 5 gives me 8. The cubed root of 8. So you have to think about what times what gives me 6. And 2 is the cubed root of 8. 2 minus 6 gives me a -4. So that is my output, number 1.